Hello students, how are you all? I hope you are doing well. So welcome all of you at AriserTalent, and I'm your physics teacher Preena welcomes you all. So previously we have a discussion on our chapter that is about the magnetic effect of the electric current, and in our last lecture we have discussed about the AC generator. So today we are going to discuss our next type of the generator, which is our DC generator, and it is known as the direct current generator. So our today's topic is about direct current generator. Second type of generator we have is DC generator. Now, this DC generator is actually known as direct current generator. It means direct current will be produced in this type of the generator. Now, firstly, before starting its construction part, let us draw me the schematic representation of this type of the DC generator. So, what it basically consists of? It basically consists of two magnets, that is a strong magnets, and they are the horseshoe magnet. Now, this is the diagram for DC generator we have. So firstly, what I have taken, I have just taken a strong magnets, and these are the permanent magnets which are the horseshoe magnet type having a north pole and south pole. So what is the first thing we have taken in its construction? So basically, in the construction of DC generator, the first thing we have considered about the field magnets. First thing I have taken is field magnets. Now, in this field magnets, we have a two magnets which are a horseshoe magnet having a north pole and the south pole. So, what we have? These are the horseshoe magnet having two poles N and S. So this is the two poles of the magnet we have. Now, after taking the two magnet, we have just placed an armature in between the north and south pole. We have just placed an armature, and I can name this armature as A, B, C and D. So you can see that how armature, it is made up of the soft iron core and it is placed between the two poles of the magnet, that is north and south pole. So the second thing we have taken is armature, or we can say that it is a coil. This armature is basically made up of the soft iron core. It is a soft iron core and named A, B, C, D. So it will be the name of this coil. Now, after this, we have taken a shaft here. This is a shaft we have. This armature is having a two ends, and you can see that these two ends are connected with the two half rings here. So this is the basic difference between the AC generator and the DC generator. There we have taken a full rings. But now in this case, we have taken the two slip rings and these are the half rings. So we can see that these rings are known as the split rings. So the third thing is about split rings. Third thing we have taken is split rings. Now, these split rings are half rings named as S1 and S2, and you can see here these two rings are actually connected with the two ends of the armature. With the ends of the armature, we have connected these two rings, and these are S1 and S2, and I can name it as slip rings. These are the slip rings. Now, you have to connect the two carbon brushes, that is B1 and B2, along with these slip rings. So, I have connected two brushes here. You can see here in the diagram. So, the fourth thing we have taken is about brushes. Fourth thing is brushes here, and the brushes here are actually the carbon brushes we have taken, and these carbon brushes are B1 and B2 connected with the slip rings S1 and S2. These are carbon brushes B1 and B2. Now, the whole system is connected with a source of battery, key and one resistance in the circuit. So, this is the whole picture or whole construction of the DC generator we have. This construction is somewhat similar to the AC generator, but one basic difference is there. We have taken the two slip rings here, and these two slip rings are actually the half rings we have. There we have taken the two full rings. So these rings are actually known as the split rings. So this is the construction. Just copy this construction part from here so we can proceed to our working part. Now, let's move to the working part of the DC generator. So, let's discuss about the working part. Now, these split rings are actually connected to the commutator part we have. So, I can write here, this is our commutator split rings. Now, let us start with the working of DC generator. So, now we are going to start about working of DC generator. How actually the DC generator works. So, firstly, you have seen here that we have placed a coil ABCD between the north and south pole of a magnet. If this coil is rotated in the anti-clockwise direction, I am rotating this coil in anti-clockwise direction. So, if coil is rotated like this, you can see that this AB will come on the downward part and this CD will go into the upward part. So, how I can move the coil here? Suppose this is my armature and this armature is basically placed here in the horizontal direction. If this armature is placed in the horizontal direction, I am moving it anti-clockwise like this, anti-clockwise manner. So, in moving in anti-clockwise manner, you can see that this AB will be shifted in the downward part and this CD will come in the upward portion of the field. So, firstly, when ABCD armature is rotated in anti-clockwise direction, what we can see that AB will be in the upward part and CD will be in the downward part. So, this things happens here. Now, if AB will be in the downward part, it will going to cut the magnetic field of the north pole. And if CD will be in the upper part, it will going to cut the magnetic field lines due to the south pole. So, what will happen next? AB will cut the magnetic lines due to north pole. It means it will cut the magnetic lines of north and CD will going to cut magnetic lines of south. So, this is what actually happens here. This both will cut the magnetic field lines. If they will cut the magnetic field lines, then there will be the change in the magnetic flux of the coil and there will be the induced current flowing in the coil. So, there will be the induced current flowing in the coil and we can determine the direction of the induced current in the coil with the help of the Fleming's left hand rule. So, the direction can be determined with the Fleming's left hand rule. Because if magnetic flux linked with the coil changes, then there will be the induced EMF or current in the circuit and its direction will be determined according to the Fleming's left hand rule. Suppose if this AB part is coming in the upward direction, I can say that the current in the coil will going to flow from B to A and D to C. So, if it is rotated in anti-clockwise manner, what will be the direction of current? The current will flow from B to A and D to C. It is in accordance with the Fleming's left hand rule. Now, if current is flowing from B to A and D to C, I can say that direction of the current will be BADC. So, the direction of current in this case will be BADC. Now, what will happen here when you rotate this coil in between north and south pole in anti-clockwise direction? You can see that there are two slip rings connected to it. these two slip rings will going to rotate these carbon brushes, because carbon brushes are actually connected to these two slip rings. So they will exhibit a polarity. This brush B will going to exhibit a positive part and B2 will exhibit a negative polarity. Because if the coil is rotated in such a manner that these two slip rings connected with the coil also rotates and B1 and B2 are actually connected to this part, so B1 will acquire a positive polarity and B2 brush will exhibit a negative polarity. So these brushes will have a positive and negative polarity. So if you want to connect any electric appliances like radio, TV or any of the microwave, any of the appliance of your home, so you can directly obtain this current from these brushes. So these brushes can be directly connected to that part to obtain the current in such a devices. So these brushes are actually working in this manner. So this is a whole picture when this is rotated in anti-clockwise direction. Now consider the opposite scenario. If this coil is rotated in the opposite direction, if I am going to rotate this coil in the opposite direction, what will happen? AB will come upwards. AB will come upwards. So what will happen in case number 2? This is our case 1. If I am considering case number 2, in case number 2, if I rotate this coil in a clockwise manner, AB will come in the upward direction and CD will going to be in the downward direction. So what it means? AB will come upward and CD will go downward. So AB will come upward and CD will go downward. So in this case, what will happen? You can see that these two slip rings automatically connect to their brushes and changes their position. It means if you rotate it like in this manner, these slip rings will going to automatically connect with the brushes, but you have seen that the polarity of the brushes will not going to be changed. It means there will be the same current flowing in the circuit. So I can say that in the DC generator, what you will get only one current, that is a constant current. So this is the basic difference between the AC generator and DC generator. If you move this coil in a clockwise manner, these slip rings will change their position and they will automatically connect to the brushes B1 and B2, but the polarity will going to remain same in both the cases. So we will get only the one current in this circuit. It means there is only one single current passing in the DC generator. So that's how it is different from the AC generator. So this is all about the AC and DC generator we have discussed here. I hope this DC generator has been clear to you. So if the question arises in your exam, what you have to do? You have to first write the definition part. Then you have to write the construction, working, direction of the current, and you have to draw the clear picture of this diagram. So these questions may be asked in the exam in 4 to 5 marks question about the working of AC generator and DC generator. Now, what is the basic difference you have recognized in these two generators? You have just seen that there is only one difference, that about the slip rings. In case of AC generator, you have taken a complete rings. You have taken the two slip rings which are the complete rings. But in the case of the DC generator, what we have done? We have taken the two slip rings which are the half rings. So this is the basic difference between AC and DC generator. So the difference between AC and DC generator is only about slip rings. This is the only difference between AC and DC generator. That in AC you have taken the two complete slip rings, and in the DC generator we have just taken the half rings. So this is all about the generators we have discussed. This is again a very important topic. So go through each video lecture very thoroughly. So this topic might be clear to you. So this lecture is over here. Thank you so much and have a nice day.